Welcome to this informative video featuring Haley Hoffman, a skilled solution design engineer for Optilogic. In this video, Haley will be sharing her expertise and showcasing the candidate facility selection database template, available in Optilogic's resource library. This powerful database allows users to leverage network optimization techniques to identify the ideal locations for new facilities and determine the optimal flow of products from those facilities to customers. By utilizing a pre-identified pool of candidate sites and applying the solver function, this approach offers a strategic way to make data-driven decisions for facility selection. So get ready to unlock the full potential of this innovative solution and gain valuable insights into optimizing facility selection with Haley as your guide.
Let's get started. Here I have a baseline map with 50 facility candidates in green, located throughout the United States, as you see here. We also have customers scattered throughout the United States as well. Some questions that we're going to answer are: what is the optimal DC footprint to serve our existing customer demand? How many facilities should I choose? And where should those facilities be located? Some data elements that we need to feed into the model that was powering the map that you just saw include the facilities. So a list of 50 potential DC locations that are entered and geocoded right here. We also have our list of customers with their locations, and these are the customers that we want to serve with our new DC footprint. Next, we have the customer demand. These are demand records for the customers that will drive the model in its decision-making about which facility should serve which customer. We also include policies, business rules for how finished goods flow from the DCs to the customers, production and transportation policies, and then we also include the facility count constraint. This is where you can set up your pool of DCs and constrain a minimum, maximum, or a fixed number of facilities. And this constraint value that you see here is going to be adjusted for each scenario that we run. Next, we will set up and run 20 different scenarios looking at what should the optimal footprint be given this number. So I have set up these first 20 scenarios that you see here, everything from 1 DC all the way up through 20 DC selected. And if I click into the scenario item here, you can see just how simple it is to set up a scenario in this way using the facility count constraints table and updating that constraint value. I'll set up an example here of the 30 DC selection scenario. So this is going to ask the model to pick the optimal 30 out of 50 locations. I set up that new scenario and then add a new scenario item pointing to the facility count constraints table, using IntelliType to pick the constraint value as the field that I'm going to update to 30 DCs. The next step is to run these scenarios, and thanks to the power of hyperscale, I can run everything in parallel, so I can answer all of these questions in the time that it takes to answer one. We can choose the resource size, so how much CPU and how much RAM to throw at these scenarios. These are simple, small scenarios, so I'm going to select the 2XS size resource here. And next we select the engine. So NEO for network optimization, Throg for discrete event simulation. This is a NEO network problem, so I'll leave that selected and use the transportation policies for the lane creation rule. Now we kick off the solve and watch the hyperscale in action. Here, as I navigate over to the Run Manager, you can see the 20 scenarios running in parallel. They take just a few minutes to solve, leveraging the hyperscale ability of the cloud to run everything in parallel. So I get more answers quicker than ever before. After the scenarios run, all 20, I can review the outputs in a few different tables in the output section, starting with the optimization network summary for the high-level summary statistics for all 20 scenarios, and then focusing in on the optimization sites to figure out which sites are selected for each scenario. Here I'm going to filter on the 5DC scenario and see which sites were included in this optimized 5DC version. I've got Atlanta, Chicago, Dallas, LA, and Philadelphia, and you can also visualize these results on the map. So I see those 5 DCs from the optimization sites output located throughout the country and which customers are assigned to those facilities as well. Clicking through the best 10, the best 15, and also the best 3 DCs, we can answer the question, which are the best locations given these inputs? We can further the analysis and assess the cost, service, and risk trade-offs for each scenario. I've created a sensitivity analysis here to determine how many locations to open. And you can see that curve start to flatten out after 6 DCs, where the transportation cost benefits start to decrease. We can also assess the service level. So here in the red line, the volume that's delivered is the same for each scenario. So each network is working to fulfill 100% of customer demand. But the yellow bars are showing the average distance traveled out to the customer. So you can assess different service level requirements here. If you want all customers to be served within 350 miles, then the 5 DC scenario fulfills this objective. Finally, we move on to the OptiRisk score, the output of our risk rating engine. And here we identify and quantify risk for every scenario. This is automatically calculated whenever you run optimization or simulation. You can see the components here of the DC risk scores, which include elements like distance from a level 4 biolab and a nuclear power plant. And you can use these risk results as part of your analysis to drive your decision making when determining where to open your new DCs. Thank you for watching this candidate facility selection demonstration, and happy modeling!